Hello, dear follower of geometric designs. The topic of this tutorial today is ARCHICAD Complex Roof Design. ARCHICAD Complex Roof Design. Now, before I proceed in this tutorial, let me give you a little introduction of what a complex roof design is all about. ARCHICAD Complex Roof Designs, Calculations and Settings. ARCHICAD Complex Roof System is a system of roof where there are two or more varying roof levels. In complex roof system, there are stepped levels where some roof levels are projected up above others. For instance, the design above. Take a look at the design we are referring to. You can see this simple bungalow has stepped roof levels, where some levels of the roof are higher than others, like here and this point. Now we have this sample of building that we are going to install the roof upon. Now we are going to use this particular building, to show you how to design the roof plan of this kind of building and as well as to install it. Let's proceed. Now, to design the roof plan of a complex roof levels, we use the manual method of roof design. The manual method of roof design involves treating each plane of the complex roof as single plane. For effective execution of complex roof design, there are terminologies we must consider. There are roof base thickness, II, roof base offset to home story or reference level, III, the horizontal extension of the higher roof into the lowest roof. IV, the step level difference. V, roof pitch or roof angle. VI, roof thickness. Let's go to our drawing board. Let's explain some of the things. Now, let's open section 1. Let me show you something in section 1. Now, take a look at this section 1. When you talk about roof base thickness, first, highlight this roof. When you highlight this roof, you observe that you have this dot here. This dot is a hotspot. This dot is also a hotspot. Now, the thickness from this hotspot to this hotspot is what we call the roof base thickness. If you don't call it roof base thickness, you can call it the vertical height of the roof edge. Then let's proceed. Another one we made mention of there, roof base offset to home story level. Roof base offset to home story level. Let's go to our drawing board. Now, this is what we call roof base offset to home story level. In this our diagram here, look at what we mean by base offset. Can you see? Base offset to home story. This is story 1. Now, this is the base of this roof. This spot, this hotspot point, this lowest hotspot is the base of the roof. Now, the gap from this point to this story level is your base offset. The term we assign to it is delta. Look at the term, delta. Is a sign of increment in calculus. Now let's move to the next information there. That is III. The horizontal extension of the higher roof into the lowest roof. Let's go to our 3D. Let me show you something. The horizontal extension of the higher roof into the lower roof. Take a look at this 3D here. You can see this roof projected into this lower roof. Likewise, this one is projected into this lower roof. Take a look at this one here. It's also projected into this lower roof. Now, the degree of this projection of this higher roof into this lower roof is the same degree of projection of the parapet into the building. The same degree the beam also have its projection into this place. What it means is that before you start projecting a roof into this building, you must first of all project the beam inside and also the parapet. If you don't project the beam inside, look at what you will have. Let's look for the section of this building. Okay. Let's cut this. This is section 03. Let's open this section 03. Let me show you something. Now take a look at this section 03. You can see part of this beam. Let's highlight the beam. Part of this beam projected into this building. And the degree of projection there is 1191.8. Can you see that? Likewise, this parapet also projected the same amount of extension into this building. The same thing applies to the roof. It means that if this beam is projecting 1191.8 mm, the same value will the parapet also project. Likewise, the roof will also project the same amount into the building. Now, why is it necessary that this beam parapet and roof should project inside. Now let me show you something. Let's assume we did not project this beam inside this building. Let's draw it out a bit. Let's also bring this parapet out. Let's leave it at this position. Now let's take it in 3D. Let me show you something there. Now do you see what happens? Do you see what happens? The moment you leave the beam to just end at this spot and the parapet to end at just this external surface of the wall, you will have this challenge. This is the challenge you have. You will have it open. Now, what the challenge we then have is to know the amount of extension of this parapet into this building and the amount of extension of this beam into this building. That is what we need to do. Let's continue. Let's proceed. The fourth item we have here is the step level difference. The step level difference. Let me show you what it means. When I say step level difference, I mean the height difference between this lower wall here and the beam that goes up on top of it. Let me show you in 3D. Now in 3D, you can see that this level seems as the common level of our, the final level of our building wall. These are the final level of our building wall. Now, any other structure above this level becomes an additional height extension. It becomes an additional height. Now, this extra height from this spot to this spot, that is the thickness of this beam, is what we mean by this step level difference. So when I say step level difference, I am referring to the height of this beam, which projected up from this final level of our wall above it. The same thing applies here. Can you see? This beam also, the height from this spot to this spot is your step level difference. If you turn towards this side, can you see this beam? This one seems like it is the tallest. Now from this spot to this spot is your step level difference. If we also use this, our sample building that we are going to design the roof, take a look at this beam. If you take a closer look at it, you see that the final level of this building ended here. Follow my mouse. Now, all this extra height you see here are additional height because of what we want to achieve, the design we want to achieve. Now, this extra height is what we call the step. Now, let's look at the fifth item. Roof pitch angle. Roof pitch or roof angle. Let's go to our drawing board. Let's go to section 1. Now, in this section 1, when I talk about roof angle, the angle, the plane of the roof. This is the plane of the roof. Follow the cursor. This line here is the plane of the roof. Now, the angle, the plane of the roof makes with the parapet top. This is the parapet top. Can you see? Can you see the dotted line? The parapet top. If you don't call it the parapet top, you call it the roof level. The angle, the roof plane makes with this horizontal line here is what we call your roof angle. If you go to your roof setting, this is what we mean by roof angle. Can you see? This is your roof angle. Now, let's look at the last item. Roof thickness. This is what we mean by roof thickness. Can you see it here? Because this red line is perpendicular to this plane and also perpendicular to this plane. That is why I use that term, perpendicular thickness of the roof. So this is the thickness of the roof. Now, let's proceed. To obtain the roof base thickness, of a roof, we use the formula V equals to T over cos theta, where V is the roof base thickness, T is the roof perpendicular thickness, and theta is the slope angle of the roof. Let's go back. Now, what I simply said above is a relation that helps us to get this base offset. This base offset here. I am trying to get a formula that will connect this thickness, this roof angle, and then use it and get this base offset. First, this thickness, this roof angle, connecting both of them to derive the value of this base offset. That is what we are heading to. Now, the first thing to do there is to use this formula V equals to T over cos theta. What is this formula all about? That is what I want to explain. This V here stands for this thickness from this spot to this spot. Let me highlight this roof. From this hotspot to this hotspot, I said earlier it is the vertical height of the roof edge or the roof base thickness. That is what it is. This value here. That is your V. Can you see? I assigned the term V to it. Now, to get this thickness here, you have T which is this thickness here. Perpendicular thickness. Can you see I assigned a T? Now, if you know the thickness of your roof, which is this. If you know the thickness of your roof, which is this, and you have your angle, which is the roof angle, with these two terms, we have a formula. We have just these two terms. We derive this formula. V equals to T over cos theta. What is this T? This T is this thickness here, this value here, that is your T. So when you see this T, it's referring to this value. And this theta here is referring to this 45 degrees. So if you have this your angle and you have this your thickness, all you need to do is to bring it into this simple equation and get the value of V. Now, the moment you get the value of V, you substitute it in this second equation and that gives you base offset. Now, this second equation here, delta equals to plus or minus D minus V, is the formula you use to obtain the value of the base offset of the roof. This formula gives you this. This formula gives you this. This particular formula is to get the value of the vertical height of your roof edge. Let me repeat it again. This formula, V equals to T over cos theta, helps you to get this thickness from this spot to this spot. Now, the moment you have this value, what you need to do is to substitute it in this second equation and you get delta. This delta here is this base offset. This delta here is this base offset. But I know the question you'll be asking me, what does this Z represent? And what does this plus or minus represent? Now, this is what D represents. D, this D here, is the distance between the story level, this story level, and the roof level. Are you observing something there? This gap from this spot to this spot. Let me use a line and show you. Let me use a line. This is your roof level. Can you see? From this spot down here. You see? From this spot down to this story one is your D. That is your D. How to get it? You don't need to do calculation to get it. What you need to do is just to take this your measurement material, pin it at this spot, and take it down here. Of course, you see what you have there, 977.9. That becomes your D automatically. That's your D. So, once you have it, you just write it D. And you have already gotten V by calculation. Then substitute it here. That will give you the value of this delta, which is your base offset. Now, let's proceed. What does this plus or minus sign represent? This plus or minus sign defines the position of the roof level with respect to the reference level. This plus or minus defines the position of the roof level, this level. Can you see this level? That is your roof level. Can you see it? I labeled it here, roof level. That is this dotted line. So, the position of this your roof level with respect to the reference level. When I say reference level, I'm talking of your story level. Story level or reference level. Why do we call it reference level? We call it reference level because that is the level where you drew the roof plan. If you are drawing this roof plan on this story one, this story one becomes your reference level, or it becomes your home story for the roof. So every element, every building component you are designing in ARCHICAD must have a home story where you install it. So if you are installing this roof on this story one becomes the home story of this roof. If you are installing this roof on story 2, which is this story 2 here, this story 2 becomes your home story for the roof. Now, when you have plus or minus, like I said, it defines the position of this roof level with respect to the story level. For instance, here, this roof level is above this reference level. Can you see the reference level line? It's above it. In that case, since this roof level is above this reference level, we make use of positive sign. D becomes positive. In that case, whatever measurement you obtain here, you leave it as a positive value. But if this roof level is below reference level, as in the case of using story 2 as your reference level, assuming you are drawing this roof plan on this story 2, this story 2 becomes your reference story, or you call it your home story of the roof. In that case, you can see this roof level is below it. This roof level is below it. In that case, if you measure the height from this spot to this spot, whatever value you obtain there, you assign a negative sign to it. In other words, that value becomes a negative value. I hope that is understood. Let's proceed. Now we have a question. Design the complex roof of the building above using manual method. Given that roof thickness T equals to 350, roof angle 42 degree, H1 2000, H2 1500, H3 1000. By calculation, find the horizontal extension of each stepped level into the lowest roof level. II, the roof base thickness. III, the roof base offset of each step level. Now, the first item we have here is the horizontal extension of each step level into the lowest roof level. Let's look at the information there. The formula for finding the horizontal extension of the higher roof into the lowest roof is given by x equal to h over tan theta, where x is the horizontal extension of the higher roof into the lowest roof. H is the step level difference. It can also be called the height difference between the higher roof level and the lowest roof level. Theta is the roof slope angle. Let me explain this formula. Now let's go to section 3. Watch out in this section 3. I have h here, I have x. Previously I told you this x is the degree of extension of this beam into this building from this external face of the building wall. This is the external face of your building wall. From this point, let me use my measurement material. From this point to this point, what you have there is your x. Now, to know the value of this x, you make use of the height. This height here, the height of this beam to this point, and the angle, this angle of the roof, which is theta. When you bring them together, when you bring h, x, and theta together, when you bring them together, they give rise to this formula, x equals to h over tan theta, where x is this horizontal extension here, from this point to this point, and your h is from this point to this point. That is the height of the beam. That's what you use. Or, let me show you in 3D. This is your h, this beam, for this particular section. From this point, let me use my measurement material. From here to here becomes your h. For this section too, for this particular section, from this point to this point becomes your h. For this section too, from this point to this point becomes your h. Now, these things are the step level difference. Step level difference. Why? Because they are varying heights. This one is 1000. This one is 1005. This one is 2000. They are not uniform. Because they are not uniform, you treat them section by section, part by part. Let's go back. Now, in that our question, we are demanded to find horizontal extension of each step level into the lowest level. What do we mean by that? The question demands that we should find the amount of extension of this beam into this place, the amount of extension of this section of beam into this place, and the amount of extension of this section of beam into this place. Now we are going to regard this, we are going to start with this beam section and call it our height 1. We will treat the height of this beam here as h1, and treat the height of this beam here as h2, and treat the height of this beam here as h3. To know the amount of extension into this building, let's go to our calculation board. Let's start. The horizontal extension of any higher roof into the lowest roof is given by x equal to h over tan theta, as I've explained earlier. When h is 2000, that height of 2000, that h1 you see here, h1 2000, h2 1005, and h3 1000 are the height of this beam. The height of this beam here is 2000. The height of this beam section is 1005, and the height of this beam section is 1000. So let's proceed in our calculation. So when h is 2000, simply replace this h here with 2000. Your theta is 42. Remember, theta is the roof angle. Remember, it mentioned it here. Roof angle, theta, equals to 42 degrees. So, by substitution, tan 42 will give you 0.9004. If you perform simple arithmetic operation here, 2000 divided by this figure, it gives you 2221.2 millimeter. Now, you go to section 2. That is, when h is 1500, that is for this beam here. When this height, the height of this beam is 1500, you substitute for h 1500 over tan 42. The roof angle remains the same, it doesn't change all through. So when h is 1500, by arithmetic operation, you know 1500 over 0.9004, that gives you 1665.9 millimeter. If you try the same thing on section C, which is this beam here, when this beam is 1000, then 1000 over tan 42, by arithmetic operation, the value gives you 1110.6 millimeter. Now, the moment you arrive at this, you have answered the question. Now that you have obtained this, what you do is go back to that drawing and install it. Just go to the drawing and extend them by the values you have here. So we'll start with this value, 2221.2. So we are going to project this beam. We are going to project this beam by 2221.2 millimeter into this building. Let's go to the floor plan. Now pick a line. Draw a line at this spot. Remember, I drew a line from the external face of the wall. Then select the line and drag it inside. Type in the figure of that extension, which is 2222.2 millimeter. 2221.2. Click OK. It stops there. Then highlight this section of the beam and extend them to this line. Now come to this. This is beam 2. Beam 2 section. What is the value of each extension? 1665.9 millimeter. Now we go back to the building and take a line, draw a line here. Draw a line here as well. Now if you watch out, you see that the length of the beams are not the same. That is why I have to draw different lines for them. Now highlight this line and extend them inside by that figure of 1665.9 millimeter. That done. Then drag this line, this wall, this beam to this spot. Also drag this one to the position of this line. Then delete the line. Now the third section of beam is this beam of 1000. Pick a line as well and draw at the external face here. Also draw it here because the length of this beam and this are not the same. Then highlight it and check the extension for it. The extension is 1110.6 millimeter. So we go back and extend that line by 1110.6 millimeter. Then highlight this wall and extend it to this spot. Highlight this one and also extend it to this line. And delete the line. Now check what you have just done in 3D and see what it looks like. You see what it looks like. Now this is what the beams supposed to be. Now the next thing we do now is we are going to install parapet on this building. But to install parapet, we'll start with this lower level. This final wall level. Install parapet on them first. So let's go down. Now I have already prepared a parapet using a complex profile. Now what I do is go to my wall here, open my wall settings, and you can see it's already on complex profile. This is a simple profile, this is complex profile. In this, I will now click here and choose that parapet I have designed. Look at it, parapet. Now if you have problem creating this profile, this parapet profile, I will direct you to one of my videos that is on YouTube as well. It is called Custom Parapet, ARCHICAD Custom Parapet Design. That teaches how to prepare this kind of parapet. When you go through it, you will know how to do this. So let's proceed. Now that you have chosen the parapet profile, click on it and then click OK. Now the challenge you will have is to decide the base offset of this parapet. Look at it here. The parapet that will sit on this level, you must know the height position of this wall. To do that, go to our section 1. Now in this section 1, you can see the lower level, the lowest wall level. Can you see it here? That's the file. This is the lowest wall level, and you can see its top level. You can see this proof, this room story that we are using. This story 1. This story 1 is sitting on top of it, and we are drawing the parapet on story 1. If you go to our floor plan, you can see we are on story 1. Look at it, we are on story 1. Because we are on story 1, and story 1 is sitting on top of the level of this lowest wall, then that means that the base offset of the parapet that will sit, that is the gap between the base of the parapet and the top of this wall, will be 0. So just fixing 0 there. Now that is done, you start drawing your parapet, starting from the middle. That's done. Let's check it in 3D and see what it looks like. Beautiful. You can see in the 3D, the parapet is sitting on its perfect position. Now, what we do next is we draw the parapet of this section of beam. After that, we draw the parapet of this section of beam and the parapet of this section of beam. Now, because this point is the room story level of this parapet, it then means the height difference from this point, that is from this level to this point, will be the base offset of the parapet that will place in this beam section, which is 2000. Since this beam is taller than this level with 2000, 2000 becomes the base offset of the beam that will sit here. Likewise, 1500, which is the height of this beam, becomes the base offset of the parapet that will sit on this place. Now, this beam here is 1000. So, 1000 height thickness. So, the parapet that will sit on top of it will now have base offset of 1000. Let's go to our drawing board and execute it. Now, I said that the beam, this beam here is 2000 by height difference. Therefore, the parapet that will sit on top of it will have 2000 as the base offset. That's done. We start from this spot to draw it. You click on continue. When information like this comes out, click on it. Don't worry, the beam will appear in its position. Take a look at it. It's sitting in its position. That's why I have to click continue. Now we come to this section of beam. The height of this beam is 1005. Therefore, the parapet that will sit on top of it will have 1500 base offset. So type 1500 and start from this spot to draw it. Click continue. Then for this section of beam, the height of this beam is 1000. So we change this value to 1000. That becomes the base offset of the parapet that will sit on top of it. Then we start drawing it from this spot. Beautiful. We are done. Check it in 3D. Beautiful. You can see both parapet and the beams of each section have the same projection into the building. Can you see? The parapet is projecting into the building just the same way the beam is projecting into the building for all the sections. Now let's go back to our plan. Now, the next thing we are left to do here is to draw the layout of the roof. The layout of the roof. But we'll have problem. Why? Because some sections of this beam, the parapet on top of them are not showing on this story 1. So let's check story 2 and see if we can get these parapets. Yes. In this story 2, we can see these parapets. They are appearing here. So what do? Pick a line, your polyline, and draw the parapet layout of the entire building plan. Now, having done this, another thing you do is use Polyline to mark out the external building wall surface. Like you can see here, this blue line. This blue line shows us our external wall surface. What do I mean by that in 3D? That blue line is representing this surface, this external wall lines. And you see then this external wall surface. That is what the building line is showing. So it's not showing the internal. It's not internal wall surface. It's showing external wall surface. So let's go back. Now that we have used Polyline to draw out our parapet layout, we click on this line, get a copy of it, drag a copy of it, drop it back. Then offset these lines by the thickness. Clicking on this offset edges. Offset it to the thickness of the extension you want the roof to have from the parapet. Let me say something like 50 mm. Type OK. That's okay. You might be wondering, what does this extension here all about? Let me show you in 3D. This extension I do here is this projection of this roof. Take a look at this roof. You can see this roof is projecting a little bit from this parapet. Can you see the projection? Can you see this little projection? This is about 75 mm projection. That is what this red line that I just did here shows. I cannot draw my roof and end it at this parapet top. That means when the roof is dropping water, when rain is pouring on top of the roof, it will be dripping down on the parapet surface. But with this little projection here, it will be dropping on the ground. So that's that. Then what do we do now? We start drawing our roof plan using what? Line. This is the most important aspect of this stage of work. We have done all other necessary things that should be done. Now we use our lines to draw it manually. This is different from automatic roof, because in automatic roof, the moment you just use your roof and trace out the parapet layout and stop at the end where you started before, the roof will design itself. But you don't do it in complex roof levels like we have here. So you are going to use your hand to draw the roof. That is why it is necessary to also know how to draw your roof by yourself and not just allowing the system to do it for you. So follow me. I will jump this spot, this spot, this spot, this spot, this spot, and this spot that have projections. I will do them later. So I will fast forward this process a bit. Follow me. Now, I have finished drawing the ridges and the gutters of the areas that are simple. Now, this area that I left now, you don't draw your gutter from this spot for this section. That is why I left them. You don't do that. You don't start from here. That is one of the challenges you always have in drawing a complex roof. Now, the question now is, where do you start drawing the gutter of this place? To do that, we go back to our horizontal extension. Like I said, that the degree of extension of the beam, parapet, into the building, the same degree the roof will have into the parapet. Now, for this section that has extension of 2221.2 millimeter, as you can see here, the horizontal extension of the beam into that place is 2221.2 millimeter. It then means that your roof will also project the same value into this place. How do you do that? Use this line and start from this point. You see from this point. Draw a line of 2221.2. You see where the line stops. Now it is from this point you pick your gutter. Repeat the same process here. Drawing a line of 2221.2. Then where it stops, take a line there and draw your gutter. Now join these 2 points together. Do you see? This is where your gutter is supposed to lie and not from here. Now, in this section, we know the horizontal extension of this parapet and the beam into this place. The figure is 1665.9 millimeter. So, we pick a line from this spot and draw a line of 1665.9. You see where I stop. Now from where this line stops, take a line and draw your gutter. Stop anywhere you want. Likewise at this spot, drawing a line of 1665.9. Stop. And where it stops, take a line from that place and move it towards this place. Now, let's do some joinings of lines there. Then we come down to this section here. We check the horizontal extension there. 1110.6 millimeter. So we go back and draw a line from this point, type in a distance of 1110.6. Wherever I stop, take a line from that place to get your gutter. Repeat the same thing here. A distance of 1110.6 millimeter. Wherever the line stops, take your gutter from that spot. Then let's join and finally get what our roof looks like. Follow me. Beautiful. Now we have drawn our roof plan and you can see it looks wonderful. Now that we have obtained our roof by line, what we now do is we go further for our calculation. In our calculation, this second question there demand for roof base thickness. The roof base thickness, the roof that will sit on this place, its base thickness is what we are required to calculate. Roof base thickness is constant. That is why the question is very simple. Roof base thickness. Now let's look at the calculation there. The roof base thickness is given by V equals to T over cos theta, as I said earlier. We use this value V to get this formula to get the value of V. T is our thickness as given. The roof thickness, that is the perpendicular roof thickness, 350 mm. The angle, 42 degrees. Just substitute them in this equation. T, 350. Theta, 42 degrees. We'll have V equals to 350 over cos 42. And cos 42, if you punch it in your calculator, you have 0.7431. Finally, by arithmetic process, this gives you the value of V as 471. That is what we have. 471 becomes the value of V. Now, the next question that follows there is your roof base offset, which is the third question. The roof base offset of each step level. Roof base offset of each step level. What do we mean by that? Let me show you something in the 3D. Now, in the 3D of this building, you can see we have 4 roof levels. If you wonder which levels am I referring to? This lowest level is level 1, level 2, level 3, level 4. So we have 4 roof levels. So we have to determine the base offset of the roof at this level, base offset of the roof at this level, base offset of the roof at this level, and base offset of the roof at this level. That is why we call this a complex roofing system. It's not as simple as it looks like. But with calculations, this thing becomes simple. The moment you learn this, it won't take you much time, you will just arrive at them. Why it seems like it's taking much time is because of the elaboration I have to give, the explanation I have to give so that you understand the point I am trying to make. So we'll find the base offset of the roof at this level first. So let's proceed. The roof base offset is given by the formula delta equals to plus or minus. Delta equals to plus or minus G minus V. That is the formula. Remember I said the delta is the roof base offset. Let's go to our floor plan. And this section 01. Let me open this section 01. I said this base offset here. To know this base offset, you use this formula. This figure here is base offset. Or if you go in your roof setting, like I said earlier, this is your base offset. This figure here is this delta. The value of this delta is this figure. So, because it is a complex roofing system, each level will have a varying base offset. Each level will have a varying base offset. Each level will have its own base offset. That is one thing with complex roofing system. So, in this section here, you can see this parapet here has its own level. This parapet also has its own level. Let's go to our floor plan. Now, in this our floor plan, because we want to decide the base offset of each roof at each level, we have to open this elevation E01. This elevation E01, why I want to open it because it will show this parapet here, part of this parapet here, and part of this parapet here. Let's open it. E01. Beautiful. You can see E01. Now let's proceed. Solving for the lowest roof level. This is the lowest roof level. We want to solve the base offset of the roof level at this place. Solving for roof base offset. V delta equals to plus or minus D minus V equals to minus 962.5 minus 471. This value here is the value of D. And why is it minus? Let me show. In this E01, this lower parapet, its roof level is at this spot. Can you see the roof level here? This is the roof level of this parapet. Can you see the top of the parapet? That's the roof level. Now, the height difference between that parapet top and the reference story, that is the story 2 we are referring to, the value is 962.5. But in my calculation here, I added negative sign to it. The reason I added that negative sign is because I said, when the roof level is below the story level, the value of D becomes negative. When the roof level is below the story level of reference, the value of D becomes negative. Remember, D is the height difference between the roof level and the story level. This is your story level. This is your roof level. So we have minus 962.5. In our calculation, minus 962.5 minus 471. Remember, 471 is your roof base thickness, which is constant. Roof base thickness, the moment you get the value, it is constant all through your calculation. So, by arithmetic process, minus 962.5 minus 471 will give you minus 1433.5. This becomes the base offset of the roof that will sit on this lowest parapet. Then, the next level we move to is this particular level here. Are you following me? That is this particular level. Now, we have to find the height difference between this story level here and the reference level. Look at your reference level. Can you see your reference level? The height difference between the roof level of the parapet here and this reference level. By measurement, let's measure it out. You see what you have there? 1037.5. In our calculation, what we have there, solving for H1 minus D plus or minus D minus V, we have 1037.5 minus V is constant, which is this value you have obtained. So you don't start asking for another V. You make use of V, distance V, all through your calculation. So, but this time around, I didn't assign negative sign to this figure. Why? Because the roof level of the parapet here is above the story level. I said it earlier. When the roof level is above the story level, the value of D, the height difference between the roof level there and the story level becomes positive. That is why we have 1037.5 minus 471. It will give you by calculator. Punch it out in your own calculator. You have 566.5. Solving for C, that is H2, the beam that is 1500 mm height. That is this side of beam. What do we do there? Find the height difference between the roof level of that section and the story level. Remember, story 2 is our story level. So take your measurement material and find the value of D. The value is 537.5. 537.5. Go to your calculation board. Look at it there. 537.5. Replacing D minus 471. I didn't put negative sign to this 537. Why? Because the roof level here is above the story level. That is why the D, the height difference here, is positive. So, by arithmetic process, if you subtract 471 from this figure, you have 66.5. That becomes the base offset of the roof of this section. Now, the last section is this parapet here. Let's take a look at it. Can you see our story level? The roof story level we are referring to is this line here. That's the story level. Can you see the parapet top? Can you see? This is the parapet top of that place, which is a bit above this story level. The parapet top is a bit above this story level. Therefore, let's measure it and see the value. From this spot to here, you see what we have, 37.5. So this figure is going to be positive. So that's the value of D there. The roof level is this spot, and the story level is this spot, and the value is 37.5. So in our calculation, we put 37.5, replacing D with 37.5. We didn't put negative sign. Why? Because the roof level there is above the story level. So 37.5 minus 471. Of course, you know this is a small value and you are subtracting a big value from it. You will have a negative result, which is minus. If you punch it out as 7.5 minus 471 will give you minus 433.5. Now that you have obtained this value, you can go straight and design your roof. So let's go and design our roof. Of course, you are not drawing your roof on this plane. You just move to your floor plan at this level. This level you start. Then click on your roof. The moment you click on your roof, go back to the information that is given to you about your roof. Thickness of 350. So you type in 350 here. I've written it already. The angle of the roof as given. The angle of the roof 42 degrees. You type minus 42 degrees. Why did I put this negative sign? Because it is a manual roof. When you are drawing a manual roof, the angle of the roof you must be negative. You must put negative sign to it. Now you put minus 42. Now this is edge angle. I've explained this edge angle of roof before in the other section of our tutorial. So the edge angle of the roof must be the same with the roof angle. For the parapet to sit flat, as in this 3D, like in this 3D here, what made this roof to sit flat on this parapet is because the roof angle here and the edge angle are the same value I gave them. Let me highlight it and show you something. You see something there. The roof angle is 40. The edge angle 40. That makes it possible for the roof to sit flat, the edge of the roof to sit flat on top of the parapet. Let's go back to the roof we are drawing. So we are going to draw the roof of this lowest level. They are the first ones we will tackle. The roof of this lowest level. We'll draw them. So let's go to our floor plan. Now, having put our 350 as the thickness of the roof, 42 degrees as the roof angle and the edge angle, making sure it is 42. Don't make it negative. It has to be positive 42. Having done that, go to your model and make sure that the materials are set on. Then you go to your calculation board and check the base offset of the roof there. The base offset of the roof there is minus 1433.5. You go to your drawing board and type in minus 1433. Minus 1433.5. That is the base offset of the roof at that level. Just click OK. And start drawing your roof. Look at how you do that. Pin at this spot. Make sure you extend it to this external wall surface. Click. The eye, your cursor changes to an eye, demanding for the direction you want the roof to slope. Of course, the roof is going to slope towards this side. Or the rain that will beat on top of the roof will be flowing down this side. So click that side you want the raindrop to be flowing. And then your cursor will change to 10 point. Then start from this spot, move here, take it up to this total edge, move it up to this point, and back here. The roof there has just entered. If you take a look, if you look at it in the 3D and see what it looks like. You see, it is sitting perfectly in its appropriate position. You don't need to do any adjustment. You don't need to do any adjustment. And take a look the way it laps and covers the wall properly. Can you see it? Can you see it? Laps and covers the wall properly. So, this same process we do here, we are going to repeat it on all other surfaces that are of the same level with here. So I'll be faster this time around. Now we are done with the roof of the lowest level. Let's take it in 3D and see what it looks like. You see what it looks like in 3D. Beautiful. Now, we are going to draw the roof of this place, but this time around, we are going to change the base offset according to our calculation. Now, what is the base offset of the roof of that section? That is this side. The figure is 566.5. So we go to our roof and change this figure to 566.5. Then click OK. And then start. Let's check it in 3D and see what it looks like. You see the way it just fitted perfectly without any adjustment, without any error. Now let's draw the roof of this section, changing the base offset according to our calculation. Now the base offset of the roof of this section, according to our calculation, is given as 66.5. So we go to our roof and change this figure to 66.5. And then click OK. And then start drawing the roof. Let's check it in 3D and see what it looks like. Can you see the roof of that section is fitted perfectly well in its position? I'm sure you know what this particular roof plane is all about. That's the roof plane we used in our section 01 to explain the roof terminologies. So what we do now is we draw the roof of this section using its base offset. The roof base offset of this section, according to our calculation, is minus 433.5. So we use this figure as our base offset. Go to our section and change our settings and change to minus 433.5. And then click OK and start drawing the roof. Now we have completely drawn the roof of this complex system. So let's check it in 3D and see what it looks like. Beautiful. You can see the roof of each section fitted perfectly well in position. I hope you enjoyed this tutorial. Thank you for watching.